Hello. This video is going to explain how to enable the Assets folder in Fusion 360 and how to use my CAM tools and CAM templates within Fusion. Or at least we're going to cover how to set it up. I have another video about how to actually use the template. So first of all, you're going to come over to the CAM templates in the machining folder. Link to this folder is shared in the FRC Discord, pinned to the build channel at the time of making this video. You're going to come over to CAM templates or CAM tools, depending on what you want. And for starters, I'm just going to go ahead and download one of these templates here. We're going to go over to import them. So I've actually got two downloaded here. I've got the quarter-inch plywood template, and I've got this 4mm aluminum template. So you're going to come back to Fusion 360, and if you don't see this assets folder, your next step is going to be to go over here to the top right, where it shows your profile. You're going to go to Preferences, and you're going to come down to Manufacturer, and you're going to check this box that says Enable Cloud Libraries. See, that enables the use of assets. So you want to make sure that's checked. Once you do that, if you go to your home here, you should see the Assets folder right here. It might be, you might have to go single user storage or something, but it'll be there somewhere. Then you're going to open it up. I'm going to go into CAM templates. You see we have a bunch of templates in here. Now if I want to, let's say, install the new ones, I'm going to hit Upload, and I'm going to hit Select Files, and I'm going to navigate over my downloads, and there they are right there. You'll notice this filter set to all files. Make sure it's set to that and not something weird. Hit Open, and hit Upload, and you see it's updated the ones I already have, but you'll see that they were uploaded. Ta-da, see that? Now the timestamp on these has changed to show the current time. Similarly, for your tools, you're going to go over to Machining, come over to CAM Tools, and you can download these, the .tools, and you can just import them right over here. One quick thing, I also have a draft of a unified guide for FRC machining. This is not completed at any means. It's only the first few lessons are in there, but it definitely has a lot of interesting information. It has some references for the Omeo and Tormach, like, you know, their cutting sizes and stuff like that. Just some basic stuff. Once your assets are in here, you should be able to use them. So, for example, I'm going to go over to Random, and I'm going to go open this chain holder. This is like one of my go-tos for when I'm trying to test out a template because it's a very simple part. I'm going to go ahead and minimize this. So to use my templates, I guess we'll get to that in this video too. Go ahead and hit Setup, and you're going to go to Stock, and you're going to make the stock a relative size box with no additional stock. So it's going to size this yellow box around all of your parts without adding any extra size to it. You're going to go back to the Setup tab. For the orientation, you want to make sure your Z-axis is pointing up, and the X is pointing the short way, and the Y is pointing the long way, because that's usually how it's set up on routers. So first, I'm going to change from model orientation to select Z-axis plane and X-axis. So for the Z-axis, I'm going to go ahead and select this top face, and it'll point the Z-axis up out of that face. See that? And then for the X-axis, I guess I'll go this way. And finally, for the origin, I'm going to go ahead and select here. And you'll notice that the axes are actually flipped, like the wrong way. So I'm going to hit Flip X-axis, and it'll flip the Y along with it. And there you go. Now we're perfectly aligned. Hit OK. No model selected, all will be used. Yeah, I want everything to be used. Once you have your setup, you just right-click, hit Create from Template. If you don't see anything here, you'll select Template, and it'll pull up this window, and you can go to My Templates and find the cloud templates or local ones. So the place where I uploaded the assets is a cloud template. There's also a local folder for these. I don't remember exactly where it is, but you could probably dig it up somewhere. Yeah, I've got no idea. There's probably some way to do it. You're going to go to Cloud, select, let's say I want to do this all with 4mm end mills, so I'll do that. Bam. You'll see these guys come in. For the boring operation, all of these are set up to be as few clicks as possible for the end user. So you just select for 0.196 boring. This is going to do bore milling of a 0.196 hole with a 0.015 inch pitch. This is probably a little, you can probably go a little more aggressive than this, but this is just a safe template, you know. Click on one of the holes, and bam, it'll automatically set all the others. If you're not sure which holes are 0.196 or close, you can just roll over it, and it'll tell you, see diameter 0.196. If you only want to do the holes on one of these, you can select a containment boundary. But if you want to do all the holes, you can just have all of them do it. You don't have to set the top or bottom of each hole or anything weird like that. These are all sized so that way they will start drilling from the stock top and end drilling 0.07 inches through the bottom. Hit OK, and bam. We can make sure this worked properly by simulating it. If we hit play, you can see, oop, that's too fast. You can see there it's doing the boring operation. It's helixing into each hole. Second drill, this is just a plunge drill, so it's just going to go straight down, a chip breaking partial retract. So it's just going to go down and then up a little bit and then down and then up a little bit just to break the chip and stop it from forming a big bird's nest. So we can leave all these at the default because it's sized for the 4mm end mill. So for example, these are a little too small for this end mill, but let's pretend that they're 4mm holes. Then I'll just click on it. And for the hole faces, I'll go to geometry hole face, I'll click on it. Hit OK, bam, it's done. For the last three, all you have to do is select the outsides of each part, like that, and like that. And I'll go over what these do in just a second. You can ignore this cusp height thing. I can't figure out how to get rid of that error without trashing the thing, so I just leave it. Cool. Now what do each of these do? So first of all, there's this pocketing. So the pocketing operation, you'll notice, all use the same T1. They all use the same 4mm end mill. It's been undersized to 0.152 because to make it cut a little bit bigger in case the end mill wears down or the gantry deflects. Now, for this pocketing operation, it's going to cut out all the large pockets. So we select a machining boundary, and it'll automatically cut everything inside the boundary, in which case it's just these 4 pockets. It's going to start 1/100 of an inch from the top and end minus 0.06 from the bottom. This is so that if you don't have any kind of negative offset on this, it'll actually try to face off the entire top, which is just a waste of time. So I have it start just a tiny, tiny bit below the surface. You can probably even reduce this number. The passes tab, you'll see we have a tolerance set and optimal load. This is like the width of the cut. I've got a minimum cutting radius set. We've got stock to lead, so we leave a little bit of stock there for finishing. 5/1000 is quite a bit, actually. Normally I'd go like 2 or 3, so this time it might not be perfect up to date, but this will work great. This is fine. Finally, for linking moves, we have a 4-degree helix, and we have a minimum ramp diameter of 0.035, so it won't try and go into a tiny, tiny, tiny hole and bore that out. Other than that, that's pretty much it. So we can hit OK, and it'll generate the whole operation for us. Finishing pass is similar. You'll notice this is cusp heighter we don't care about. Same thing as a lower feed rate for the finishing pass. We select the outside boundaries. It cuts, starting a little down from the top all the way through. And it just does one pass to machine out each pocket. And that's pretty much it. So now that everything's generated, we can go ahead and view this whole thing. So let's simulate it. There's that boring operation we saw before. All right, now it's doing the plunging, and now it's doing the pocketing. Obviously, in real life, it won't quite be this fast, unfortunately. And you can probably speed this up. I would say these are pretty well sized for a machine. There's a finishing pass. What was I saying? These are pretty well sized for a machine that is using just air blast maybe, or like light mist coolant. That said, if you want to be super safe, I'd slow these down maybe 20% if you're not running mist coolant, if you're just running an air blast, and I'd slow it down as high as 30 or 40% if you're just running without any coolant at all. And then, you can ramp it up slowly as you go. Like if you're using Hu-Hao end mills, which are generally kind of medium quality, low quality things, you'll probably want to run those slower speeds when you don't have coolant. But if you have coolant, or if you have an air blast, maybe you can crank it up to like 100% or 20 to 50% higher if you're using something nice, like a Thrifty Bot or West Coast Products or a Gruen end mill. Yeah, you can see it's doing the cutout now. It takes several passes. Again, you can probably ramp up the depth of those passes or the feed rate, but there you go. All done. All the templates are pretty much the same. So for example, if we want to use a 6mm and drills template, so this will drill holes and then use a 6mm to do the pocketing. Same thing, we just select one, so 0.196 drilling, we select a single hole, selects all of them. 0.59 drilling, If this was 0.159, we'd select it. Pocketing, we just select the outsides. Cuspite error, we ignore. And there's the cutout. There you go, all done. This 3D adaptive can sometimes take a few minutes to generate, especially if you're running on kind of a slower computer. That's why I typically encourage people to generate their G-code at home and just like put it in Slack or something or share it some other way to run on the machine the next day. It just tends to speed things up. And there you go. This whole job is going to take us, I'm just going to say this. Here you go, 5 minutes and 43 seconds, theoretically. There's tool changes in this one. T3 and T6, they're tool changes. So to separate those into a separate G-code, I'm going to hit Control-D, duplicate that, duplicate it again. And in the first one, I'm just going to run tool 3. Second one, I'm just going to run tool 6. And there's other ways to do this, by the way. This is just like the easiest way to do it. You can set up like M0 stops and things like that. And I can have 3 setups, each with 1 tool. So now I want to generate the G-code. We just click on a setup, post-process. We select the post-processor, so if you use the Avid CNC Mach 3 mil post, that's what I recommend. You can output a new folder. You can name it something. Test part. Make sure units in millimeters if this is on Omeo. Some machines will support both if they have a better control system, but millimeters is best for Omeo. You can open the NC file in editor if you want to check it out. All that stuff. There you go. And you can see it's opened up the G-code for me. You see that just the drill was selected, so just the drill is being machined. And that's it. If you have any questions, you can always reach out to me on Discord or Chief Delphi or just through email or something. My email is anandmeep@gmail.com, ANANDMEEP@gmail.com. Make sure that if you're a student, you're always messaging a mentor with another student, or even better, a mentor CC'd on the conversation. So if you're going to DM me, try and make it a group thing, or just ping me in the FRC Discord and I will respond. So yeah, I hope this is helpful, and have a good one.